Welcome to Academic Digest class. Today we're going to do scalars and vectors. Here they said explain addition and subtraction of vector. Very well, you know that vector is defined as quantity with magnitude and direction. So let's start with addition and subtraction of vectors. So the explanation I have for this is that in adding vectors, we have what we call triangular method and parallelogram method. They are both the same thing. Let's say, for example, I'm adding a linear vector. If I have this to be 5 and I have another vector this way, provided that the height of these two, the length of these two are the same, means that this is also 5. So all I just need to do is to say, let's say call this A, call this B. I'll do A plus B, which is the same thing as in 5 plus 5, which is equals to 10. The units, if this is in Newton, this is in Newton too. And let's say I have this, and then I see another vector moving in this direction. If this is B and this is A, this means that this is going in opposite direction. So I'll say that this is negative B. And to add this vector, I'll simply do A plus minus B, which is the same thing as saying A minus B. But notice that this is not always the case. We can have a case where we have two vectors. One moving in this direction, another one moving in this direction. Let's say this is x-axis, let's say this is y-axis. Notice that this part, we'll call this the head. We'll call this the head. So notice that this one has a part, a end, a tail, which we'll call the terminus. The two of them, they meet somewhere. So when I had tail and tail, when I have tail and tail, we'll call this the triangular method. So to get the resultant, I'll simply do this. Notice that it's starting from here to meet this. This becomes the R. And to get this, we simply use Pythagoras theorem, which is the same thing as saying R square is equals to y square plus x square. But you need to know that this Pythagoras theorem is coming from cosine rule, which is r square equals to y square plus x square minus 2yx cos, and this is 90 cos 90 degrees. And you know that cos 90 is going to be 0. So 0 times 2yx is going to be 0. That's minus. So you see that everything here is dead. It will cancel, it will go out. So you're just left with this. So that is how we get Pythagoras. And now to get r, you simply do square root of y square plus x square. So that is for the first method of adding vectors. So I normally tell my students, when the angle is 90 degrees, when you get angle 90 degrees, simply use Pythagoras method to find the resultant. But when the angle you are given is less than 90, acute angle, or more than 90, I normally tell my students to find the resultant, use cosine rule or parallelogram rule. They are the same thing. Or use parallelogram rule. See what I mean? Let's say I have an angle here to be 50 degrees. And let's say this is A, this is B. Notice that this is saying, in this case, this is the same thing as having, let me analyze it. This is the same thing as having this to be moving in this direction, A, then this one to be moving in this direction, B. Notice that they have the tail and tail here. Now, what I have here is also equal on this end. Then what I have here is also equal on this end. Now notice that the rule says that the diagonal gives you the resultant. So this is the diagonal. This will give me the resultant. So if I want to redraw this now, notice that this part of this looks like a triangle. I now have, and notice that this is the same thing with that your method, that first method, because I now have the head, then I have this. So notice it's the same thing with what I have here. Because here I have head. this way, then I have this coming to meet this. So which is the same thing with assuming, see what I mean? Assuming I have this like this. Notice that if I have this is the same case as saying coming here. Okay, if I want to bring this out now, you see that this is just the same thing as saying so you see, so it's the same thing. So it's all about knowing that this side is equal to this side and this side is equal to this side. So I believe you know that inside this right angle triangle, this is also equal to this, so it's not a diagonal. So what you have here is equal to what you have here. So but in this case, notice that if I have this now, I can now have this. So if I know that, notice that, let's say this angle is 50 degrees. Let's say the whole angle here is 50 degrees, which is this now, which is, that is some part of this and then going this way, because if you remember, so if the whole thing here is 50 degrees, you now ask yourself, all this angle, everything here, they are on a straight line, shebi. So you simply say 50 and what will give you 180. So which means that there's an angle here. When you do angles on a straight line, you do 180 minus 50, 130. There's an angle here, 130 degrees. So if I'm to use cosine rule, I must make sure that the angle I'm using to put as my theta is the angle that is facing R. If you don't do it, you will fail it, because every cosine rule must be equal. The answer you get for every cosine rule must be equal to what you get for the direction, that is using resolution method. So the angle you use here must be angle that is facing this R. So notice that if I now have this, it's going to be 130 degrees here, since I've subtracted it. So if I know this becomes my A, if you remember, and this becomes my B part. So by the time you do this now, you see that you can now use cosine rule to get this. You now do R square is equals to A square plus B square minus 2AB cos 130 degrees. Once upon a time, we were solving this in class, and when we were solving, we ended up using this to be cos theta, and the angle we were using an angle like this one, which is not right. If we are to use this angle, we make sure that is when we are finding resultant to be on this end, but it's not possible. So we always use the angle opposite to the R. Notice that when you do this 130, because 130 should give you negative, and this and this will give you positive sign. That is why you have that most cases when you are using cosine to solve, the formula you use is always the one that gives you this to be almost the same thing as saying A square plus B square, because what you get here will be minus, then minus becomes plus 2AB cos theta. So it's either you use this, when you are using this cos theta now that you're using this cos theta, notice that the theta is the same thing with this. So if you must use this theta, if you must use this formula, if you must use this formula, make sure that it is when what you have is on any part, that is on the part that is not opposite to the R. But when you notice that what you have is facing your resultant, which is the right, you employ this formula. So this can only be used when it's on the same side. When it's on the same side. So when the angle is on the same side, see it here, the same side. But when it's on a different side, see that it is from here that I put this out. So the best thing you need to notice is that You always, for cosine rule, you always make the use of the angle facing the resultant. And if you must not make use of it, you now know that if you are putting plus, you make use of your theta to be that angle before, that is the given angle in most cases, the angle you subtract from 180. So this is it. So these are the two methods of doing addition of vectors: triangular method and parallelogram method. This method is called the parallelogram method. So notice that if I have, for example, this, notice these two things. It's more like when I have triangle, this, and then I have to get something here to be equal to this. Then I have to get another thing here which will be equal to this. By the time I join this, whatever I have here is how I get my resultant, and I told you to always use this. Then if it's for triangle now, notice that I don't have to start doing this, because this, if I do this now, I can still get this side. And notice that what I have here is my R. So whichever way is the same thing. So, but let's prove now that cosine rule. Let's prove that we need to prove that cosine rule is equals to parallelogram rule. Parallelogram law. Notice that all these ones that we did here, what we did here is called cosine rule. Now let's see parallelogram rule. It's given by r square equals to a square plus b square minus 2ab cos 180 minus theta. This is parallelogram rule. Now, if this is the case, now notice something. Let's say I have a square plus b square minus 2ab cos 180 minus theta. By the time I do, let's say I'm giving cos to be 60 degrees. 60 degrees. Now, by the time I do cos 180 minus 60, I'll get 120 degrees. Is it not true? I'll get 120. Okay. So if I do 180 minus 60, for example, I'll get 120. And notice that this is going to be the same thing as saying cos 120 is the same thing as saying minus half. I seen it, minus half. And this minus half, times this minus. By the time you check the two of them, by the time you do this times this, you end up getting r squared to be equals to a square plus b square plus 2ab cos theta. So, and you know that when you use this theta now, when you are using this theta, is that theta that, with that explanation we did, that one is subtracted from 180 as you've done it. That's the one you put here. So you see that it's the same thing, it's giving you the same thing we have here. So I always advise my students, if you must use the angle given, if you must give the angle given, you just use this one. But when you know that you have to draw the parallelogram and the angle this place, you get it, and it's facing this side, when you are using, make sure that what you use here is minus. But if it's, for example, I have something like this and I have an angle here, let's say theta. If I'm using this like this, I'll just use this formula. But once I'm using this, facing here, I must use minus. So I think as we progress to solving problems, you understand it better. So let's move to the next question. Next question says differentiate between linear and coplanar forces. All right. If I have a straight line, this is a linear line, or you say it's linear, straight line, linear. Now any other vector I see happening around this is what I call a collinear force. Even if it's this way, let's say I have a vector going this one and another one going this one, I'll say that this vector is going opposite to this one, so they are collinear. but in opposite direction. But the minute I start to see, let's say, at an axis like this, now I come and see something like this. Notice that this is a 3D, 3 dimension. Let's say I come and see this. This is another 3 dimension. This, I see another this. So these are coplanar forces or coplanar vector, in the sense that they are happening at a plane. They are happening at a plane. Notice that this is first quadrant, second quadrant, third quadrant, fourth quadrant. So notice first, second, third, fourth. So we normally differentiate it as linear vectors are forces acting on a straight line, while that of coplanar are forces acting on a plane. So, or vectors acting on a plane. So fourth quadrant. And I know that here everything is plus plus, because this is y, this is x, positive, positive. But here this is negative. So this is going to be negative and plus. Why this side is negative y, so here is going to be negative, negative. X always comes first. Then here is going to be positive, negative. Very important to note it. So let's move to the next question. Differentiate between cosine rule and parallelogram rule. Alright, let's say I have r square. That is number C now. This is C. This is B. So differentiate between cosine rule and parallelogram. R square equals to a square plus b square minus 2ab cos theta. And remember, the theta I'm using is going to always be, let's say I have this, and I told you always use this when you use cosine rule and parallelogram rule, when the angle is less than or equal to or greater than 90. So if I have this, I have this. Remember that 180 minus 90 is 90. 90 plus 90 is 180. And cosine 90 is 0. What is doing here? If I have this, the angle I must use when I'm using cosine rule is this angle. Very important. Very, very important. So if I'm going to use anything that is not this angle, I will try my best to change this to plus. So notice this. I have a square minus 2ab cos theta. Now for parallelogram rule, r square is equals to a square plus b square minus 2ab cos 180 minus theta. See. Let's check. You see this now. So let's say this is 180. 180 minus this angle, this particular angle. If this is the theta given to me, that means that if I choose to, let's say I have 60 and I have minus 180, then I get here to be 130. Let's say I have here to be 130. If I come and do 180 minus 130 now, notice that what I will have at the end of the day is going to be, it's going to be 50 here. Or let's say I do 120, I'll have 60. I just want to use this for a reason. So I have 60. Notice that if I do cos 60, I will get half. And by the time I put this half here, the answer is still negative. I still have negative 2ab half. Then everything this side, a square plus b square. So you see, if I'm using this angle now, this angle that I must use, I told you this is the angle you must use for cosine, this angle. If I do it, notice that I have half here. And by the time I do this half minus, see that everything is giving me is the same thing. So cosine rule and parallelogram rule, they are the same when you are using the angle opposite the resultant. But for them, when you are having to use, let's say r square equals to a square plus b square minus 2ab cos 180 minus theta. Let's say you were not given this angle, and you forgot to remember that if I have something like this, then let's say I have 60 here, 60 degrees here, and you forgot that when you do angles on a straight line, 180 minus 60, that you should get 120 here, because, and you forgot to do this, then this angle you used it 60 degrees. See that by the time you do 180 minus 60, you carry this angle and put here. The angle you're supposed to put here is this one, in order to have the same thing with what's it called, with your cosine rule. But let's say you forgot and you now did 60 here minus 180. By the time you do this, you now have cos 120, and notice that cos 120 is minus half. Shebi? Yes, minus half. Now when you do this, minus half times minus 2ab, you are going to get plus 2ab, a square plus b square, r square is equals to. Now notice that this particular answer that you've gotten is also correct, but is different from this cosine rule. It's different. It can only be the same. It's the same thing with cosine rule. If you used cosine to be r square equals to a square plus b square, then you now obey this by using the that's plus 2ab cos theta, and instead of cos theta you used the angle opposite the this should be minus, you use the angle opposite the resultant, which is now 120. By the time you do this minus half, if you come and times this, it will give you the same thing. So by cosine rule and the parallelogram rule, they are the same thing. It's just that you need to understand when to use your theta. You need to know, and the key thing to understand there is that you need to know that the theta should be the angle facing the resultant. If it's not like that, there might be mistake, because everything you do as your answer for cosine rule should always equal to what answer you get when you use the resolution of vectors. So let's move to the next question. They said, when is Pythagoras? That's the next one. Oh God. Next one says, when is Pythagoras cosine, sine, and tan rule used? So I normally tell my students that it's very simple. Just maintain the use of Pythagoras when what you have is a right angle. And remember, I said you use Pythagoras when you have a 90 degrees angle. And what you use this to find is the resultant. The resultant. That's what you use it for. Use it to find resultant. Why cosine rule? You use it when you have angle above 90, obtuse angle, and angle less than 90, acute angle. So for these two cases, you use cosine to find your resultant. For here, you use Pythagoras to find your resultant. Then sine rule and tan rule is used for finding direction. So you use tan. Anytime you use Pythagoras to find your resultant, use tan theta to find your direction, which is y over x. Y over x. Then theta will now be equals to tan inverse of y over x. Then you use sine rule. Anytime you used cosine to find your resultant, you use sine rule. So let's say, for example, I have this. Let's say this is A, let's say this is B. So to find sine rule, to use sine rule is simply, I will say there's an angle here. This is my resultant. So we use sine rule when we are finding direction or angle, and the angle before us is more than or less than 90, and we used cosine to find resultant. We use cosine to find resultant in that case. Then I use sine to find my direction. So I'll simply do this angle. Each of these has an angle. Let's say I call this phi. Let's say I call this beta. I will say this angle, this particular angle, let's say angle alpha. The opposite side of it is A. So I'll simply say sine alpha all over A is equals to, this angle is angle 130. So I say sine 130. So you always do the angle all over the opposite length. The opposite length is R. So let me just put this now for case of emphasis. This particular one, angle beta, sine beta, all over. The opposite side of this, opposite length of it, this is B, all over B. So let's say I want to find these two now. I'll simply do sine alpha. I listed the 3 out for teaching sake, but just know that you always find between these two. So sine alpha can be finding 2 angles at the same time. So it's always one thing to find first. So sine alpha equals to sine 130 all over R all over A, cross multiply. I get sine alpha, R sine alpha is equals to A sine 130. Divide both sides by R, the coefficient of sine alpha. So I have sine alpha is equals to A sine 130 R. So to get angle alpha, we'll now do alpha is equals to sine inverse of A sine 130 degrees all over R. By the time you do this, you punch it, that becomes your final answer. Alright, let's move to the next one. They said find the sum of two vectors A and B given by A equals to 5 meter. A equals to 5 meter, angle 60 degrees. B equals to 6 meter, angle 130 degrees. So to get this, I'll simply do, so question what now? Question E. So A equals to A equals to 5 meter, angle 60 degrees. Then B equals to 6 meter, angle 130 degrees. So if I know this, you will now have situation of saying let A now be something of, let's say I have, first of all, to find this, I'll do, let my A be 5 meter. Let's say I have 5 meter line. Then they said angle 60 degrees. So 60 degrees. Then let's say in this 60 degrees, this 60 degrees. Now, let's say this is my A. Let's say this is my A. So let's say for B now, to find B, let's say I come and do B now is going to be, let's say this is, I draw a line. Then let's say 60 degrees. I know that first quadrant is, I always start here, 90. From here to here, 90, 180, 270, 360. I always go like this. So my 130 should be somewhere here. 130 degrees. So if I know this, let's say this is my B. See, in fact, let the arrow always represent your B. And the other one for A. So notice that I've gotten this. If you start doing this by scale drawing, they'll start to tell you things like, come and do, let's say you have this. You do A 60 degrees. Then B 130 degrees. Then alternate angles 60 degrees. What is remaining here to complete 180 is 50 degrees. altogether 110 degrees. So since I don't want to be stressing, see, it's not everybody that will know that you need to carry down 130 up. All I will just do is to simply employ resolution of vector method. And remember, if I don't want to employ resolution of vector method, I can use resultant method. I can also use cosine method. And cosine method now I'll simply do, okay, we'll check if the two will work. Let's first do resolution of vectors, then we'll come and do resultants. So let me bring out a special site for this question. So let's look at the question again. Find the sum of two vectors A and B given by A equals to 5 meter angle 60 degrees B equals. So what I will do is to, once I see any question about find vector, anything vector, just go and do x-axis, y-axis, finish, simple. If you do it now, you come and do, they gave me A to be 5 meter angle 60 degrees. I'll come back. Let's say this now. Let me draw this for A. First quadrant 60 degrees is somewhere here. This is A. So this is y-axis, this is x-axis. And first quadrant, everything is positive. So to get this now, I'll simply say employ that my method which I told you, ASTC. Away from the angle, use sine. Towards the angle, use cos. Vector is always trying to tell us that everything should be at the y-axis or x-axis. If I have anything at this angle, is the z-axis, it doesn't exist. I need to carry this. It has effect on both sides. Carry this and come to y, carry this and come to x. That is what resolution of vectors is talking about. We'll still define it in the next question. So now see that if I carry this A and do as if I'm going to y, notice that this angle will be opening. Let's say it's just like I have something of this nature and I have something here. I have an angle here. I have something this way. I have an angle here. If I'm trying to make this to go like this, to force it, that is to make this thing stand to y-axis, notice that this angle will be opening. That is, when it's opening, we use sine away from the angle. But if I have something of this nature and I have this as an angle, if I'm trying to close this, the angle will end up closing. So away from the angle, I use sine. So I will simply say, remember that A is 5 and B is 6. So away from the angle, I use sine. So this is going to be on the y-axis. A, that is 5 sine 60. Why? When I'm going towards the angle, trying to carry this to here, I'll use 5 cos 60. And that is for A. So that is for A. We have no business with B here. That is for A. We've gotten A. So for A, we do 5 cos 60 for the x-axis and B. And on the y-axis, 5 sine 60. Alright, let's go to B parts. These are two different questions, but you have to resolve it together. And it's more like there is force or there's a vector at y-axis and x-axis for A. There is vector at y-axis and x-axis for B. So for B now, minus y. So notice that this is where I have 130 degrees. And I need you to notice something. We always start from here. We say that from this end to this end is 90. Here to here is 180. Here to here is 270. Here to here is 360. Angles of a circle 360. Straight line 180. So 180, 180, 360. Straight line, straight line. So I want you to know that when you're doing this kind of question, if I'm giving this 130 and I want to use this 130, let's say I know that this side is x, this side is y. If you do it, you will get the same answer. If whatever angle I'm giving, I always want to use it like that, I will make obedient, I'll pay attention to the quadrants. I remember that here plus here x and y is plus, here x is minus, y is plus, here x is minus, y is minus, here x is plus and y is minus. So I'll simply say, if I want to use this 130 given to me, notice that it's more than the first quadrant, so it falls here. I'll just run and do minus here, plus here. I've done this in my previous video. So I will now be doing anything I want to do. But if I don't want to put this minus sign, know that all the angle always start from this horizontal, the part of 0, moving towards the 90, then going around. So what I'll simply do is to say this 130 entered this. So I'll say from here to here is 90, here to here is 180, 0, 90, 180. So see that I have 130. So 180 minus 130, this is 50 degrees. This is how I always do my own. So this 50 degrees is what I will use. So I will now obey that principle, ASTC. Away from the angle, use sine. Away from the angle, use sine. Towards the angle, use cos. So taking this away from the angle means I'm trying to go to this y-axis. I come and try and start taking this to see if it will go here. So notice as I'm doing this y, let's say when I get here, the y will be opening. So I'm going away from this angle, the angle. So away from the angle, this is going to, remember that this is 6. So it will be for the y. I don't need to put this plus when I've already subtracted the quadrants. So this will be 6 sine 50 degrees. Now, anytime you subtract and you're doing this, no need adding minus, just obey this rule. So always work. Now, taking this to x towards the angle, this is small. So I'm taking this to here, it will be closer. So we'll use cos. Towards the angle, use cos. I'll do 6 cos 50 degrees. So now that I've gotten this, remember that this is B, 6 meter angle 130 degrees, and that angle 130 degrees, you know how we'll change it to 50 by doing this thing that we did. Angles on a straight line, total 180 minus 130. So we now have this. So if we finish this now, what we just need to do at this point is to say, let's find what all this angle will give us. Let's do it. So there you have it. 5 cos 60 gave us 2.5. 5 sin 60 gave us 4.3. 6 cos 50 gave us 3.4. 6 sin 50 gave us 4.5. So we have to get the sum. So to sum this up, that is EX and Y. To sum it up, we now have that the X, we have 2.5 plus 3.9, which is the same thing as saying 6.4. Then the other one we have 4.5 plus 4.3, which is 8.8. So we've gotten a total for x-axis, which is 6.4, and total for y-axis. So what we've done is that we've been able to take this angle now, these angles, this one to y-axis and to x-axis, then this one to y-axis and to x-axis. Now when you are through with this, remember I told you if you want to use that angle given without subtracting, you can. If you, we used 50 by subtracting, but if you want to use 130, remember to obey the quadrant. So what I will do now, I've taken it. So I now have x and y axis. X now is 6.4 and y is 8.8 y x. So I can now use Pythagoras to find the resultant. So I'll now do r square is equals to 8.8 square plus 6.4 square. So whatever it gives me, I'll have let's do it, 8.8 raised to power 2 is 77.4. 77.4 plus 6.4 raised to power 2 is 40.96. Then remember, this is r square. Take the square root of both sides. This will cancel this. So I will do 77, 40.96. I have 118.36. Take the square root. So square root of 118.36. It gives me r to be equals to 10.88 as my r. And remember that this r is in meter. So it gave me 10.88 meter. So it's giving me 10.88 meter as my r. So this is when you use resolution to solve it. Resolution of vector method to solve. You get 10.88 as your r. So I got here 10.88 meter. Remember that this is in meter. This is in meter. They have the same units. So let's try to solve this using cosine or parallelogram rule. So I'll simply say these are the angles I'm given. Let me redraw for A. A is 60 degrees. 60 degrees. Remember that this should be equal on this side, and this should be equal on this end. Crazy stuff. I don't understand you. So there should be diagonal line. And when I have this diagonal line, I will say angles on a straight line is 180. So 180 minus 60, I should have 120 degrees here. Then this is the angle facing the R. Whenever you want to use cosine rule, that's one thing you need to always remember. You use the angle facing the resultant, 120 degrees R. Notice that this angle here is, let's say I call it alpha. This angle is different from the whole of this angle. You don't know this angle. So then for the 130 here, I have 130 degrees. Then let's say I have another one. Remember that if I have this way, I have this way. It's as good as saying I have another one this way. So notice that this should go to this to form a diagonal. This becomes my R. So I don't need to do 130 minus. Angles on a straight line is 180, yes. But notice that I don't have to do it because this is facing the diagonal. So it's normal that the part that occupies more of the side takes the diagonal. So I'll just use this part. This is going to be the same thing as saying B. And then notice that what they gave me for this is, they gave me this thing here to be A. This is A. They did not give me anything like B on it. But let's see if we can work with it. So I will now have so I have this side. This side is 6 meter. I have here, this is 5 meter. Okay, so this is all I have, 5 meter, 130. So let's say I have R square. Let's see if it will give us anything. We don't have A square plus B square minus 2AB cos theta. So notice that we don't have B. So this won't work using cosine rule. So we don't have the other sides. So it's better to always use resolution of vectors. As we progress, we will see questions that we can use the same formula to see if we can tackle, so that we can check if our answer will be the same. So the next question says, a man travels 7 kilometers due north and 10 kilometers east. Find the resultant displacement. A man travels 7 kilometers due north and 10 kilometers east. Find the resultant displacement. Notice that this is the sentence saying north. Remember that this is north, this is east. So he traveled 7 kilometers and then 10 kilometers. We want to find the resultant. This is 90 degrees. So the resultant is simply going to be r square equals to 7 square plus 10 square. R will be equals to square root of 49 plus 100. R will be equals to whatever you get. Let's do it. So R is equals to 12.21 kilometer. Let's move to the next one, G. If he travels 7 kilometers. So I always advise my students, whenever you are doing anything on bearing or vectors, this is for F. Whenever you're doing anything on vectors, always first of all go and put your vertical. Whenever you start to see traveled, do north, do west, always first of all go and draw your y-axis, your x-axis. When you draw this, it helps you so that you don't make mistake. So this is my minus y. So it says G, if he travels 7 kilometers north 30 degrees east, that is C. This is north, this is east. This is north, this is east. If he travels 30 degrees from the north, 7 kilometers north 30 degrees, north of east. So you see that from the north to the east, towards the east, he's moving from north of east. So 30 degrees, 7 kilometers. Don't confuse it. Some of you are used to everything about angle being like this, like covering everything. No, assuming they said east of north, you start the angle from here, but here is from the north, he's moving towards the east. So let's say you find your 30 here, you need to know that. So by the time you do this, you will now see that then on the east and 10 kilometer east and 10 kilometer east, 10 kilometer east, you move to the east 10 kilometer. So you need to know that. So now that I have this, if I want to solve this kind of question, I can employ my resolution of vectors. It's always accurate, but we'll try to see if we can use resolution and resultant to solve this now. This thing now that I have here, notice that this has created a situation for me, because now I know that the angle I have here from this end down to here like this, the angle I have is supposed to be 90. But notice that the first quadrant always starts like this, go like this. So we'll ask ourselves, angles on a straight line is 9. Angles on a straight line is 180. The one here, the first quadrant, angles on the first quadrant is 90 degrees. So I have 30 here. That means that there's an angle here, which is 60 degrees. So you see, it has created that for me. So this is also the sentence saying 60 degrees, 7 kilometers, 10 kilometers. So I can use this like this. Then remember, I will do, anytime it's less than 90 or greater than 90, I always use this parallelogram, which I told you is the same thing with cosine rule if you know how to place your angle. Now ask yourself, angles on a straight line is 180, shebi 180 minus 60, 120 degrees. So very important. So I can now use cosine rule or resolution of vectors to solve this. So let's try to use this time around cosine rule and see what we'll get. Then we'll use this side for resolution. Once it's resolution you do x and y. So for cosine, I'll do r square is equals to a square. Let's say I call this part a, call this side b. A square plus b square minus 2ab cos theta. And I remember I told you the angle you put here must be the angle facing the resultant. This diagonal gives you the resultant. So 120 degrees cos 2ab minus b square plus a square r square equals to. So notice that this will give me minus 2 into 7 times 10. Cos 120 is minus half. Then 7 square plus 10 square equals to r square. So r square is going to give me 49 plus 100 minus 7 times 10 is 70. 70 times 2 is 140. And this 140, notice that what is separating this is multiplication, times minus half. This will become minus plus 140 over 2. Give me 70 back. So I have plus 70, 100 plus 49. R square is equals to this. So R square is equals to 149 plus 70. R is equals to square root of, let's punch that. If I remove 70 here, I have 30. Guys, I have 79 inside here. So I have square root of 79, and square root of 79 is equals to R is equals to 8.89, and it was given to us in kilometers, so we'll use kilometer for that. So that is how you go about it. That is how you go about it using cosine rule. Using cosine rule, you will always find the angles on a straight line, and the angle you use for cosine rule must be the angle facing the resultant. But let's say we go back to this. Let's say we go back to this and we want to make use of resolution of vectors. So now look at this very well. Don't tell me that he's did 30 degrees. Why am I not getting this? We employ law of physics. Physics controls everything that has to do with physical. So when he's at 30 degrees from the north of east, notice that he's creating a degree here, which is 60 degrees, because we have to start from the first quadrant. I told you that this is first quadrant, second quadrant, third quadrant, and fourth quadrant. So I have to now do using resolution of vectors. Anytime you hear resolution of vectors, just go and think of x and y. How do I take it to x? How do I take it to y? Now I will say on the first part I have 7 kilometers. Then I have 10 kilometers. Shebi? Yes. Then I have 10 kilometers. Yes. I have 10 kilometers. So I will now say this now, once you are able to do this subtraction, it helps you to do things. If I carry this 7 now, trying to take this 7, this thing now, I'm saying that nothing is supposed to be here. It's supposed to be anything vector using resolution is, how do I take it to y axis? How do I take it to x axis? So carrying this now to x axis, notice that this angle will be closing. So towards the angle, use cos. So I'll have 7 cos 60 degrees. Now carrying this to y, I'm going away from the angle, use sine. This is the angle under consideration. Now carrying this way, I'm opening this angle, so I'll use 7 sine 60 degrees. Now for the second part, which is the east side, the 10 kilometers, notice that this 10 kilometers, anything that happens only on a particular axis, assuming I saw this 10 kilometers only on the y axis, let's say 10 kilometers north, it's only on y, it did not happen on the x. So, but here it's only on the x, not on the y. So this is going to be 10 kilometer for x. It did not happen on the y, 0. But let's say you want to argue it. We can have this repeated this way. This is 10. Shebi, angle between it is 90 degrees. We can say on the x-axis, let's say we are trying to take this 10 now, this 10 that is here, to the y-axis. We are trying to take this now towards this. You see that we are going towards the angle. Shebi, taking this from x to y, we are going towards the angle. So it will be cos. And when I have cos 90, is going to be 0. So 10 times 0 is 0. So going towards y is going to give me 0. Now let's say this 10 that is here, I'm trying to take this away, further away from this angle. Away is sine. So, and sine 90 is 1. So 1 times 10 is 10. So I'm using this. So now that I've done this, let's get 7 cos 90. Let's get this now. Let's see. So I get 7 cos 60 is 3.5. Then 7 sin 60 is 6.06. So if you do the summation, you have 13.5 here. Then this side you have 6.06. All right, so this is the sentence I'm saying on the x now. I have on the x I have 13.5, and on the y I have 6.06. So let's do this now. I'll use Pythagoras. R square equals to 6.06 square plus 13.5 square. So then let's do 13.5 raised to power 2. We have 182.25. If you r square is equals to, let's add it up. So let's do 36.72 plus 182.25. We have 218.97. R square is equals to, Shebi. So if we do r now, the square root of 218.97, we get square root of this, we get 14.9, sorry, 14.7, 14.8. We get 14.8 as our r. If we do it, we get yes, we get 14.8 as our answer. So let's check where did we go wrong. Okay, so what we did here is a technical error. So notice that here we did 149 plus 70. We did 149 plus 70, and that is, this is not 79. 149 plus 70 is not 7. We did 149 minus 70 instead of plus. This is plus, and this should give us 219. 219. That's the mistake. 219. So it's addition. So, and square root of 219. Square root of 219 is going to give us r to be equals to 14.8. So we are correct. We are correct. So what we did is a technical error. We subtracted instead of adding. So this is adding, and everything is in order. So we are correct. So you can see that the result we have here is equal to what we have here. So always remember that your value for cosine will always be equals to what you get for resolution of vectors, provided you remember to always use the angle opposite the resultant when you are solving for cosine. You will always be correct. There's no need trying to cram when it's different and when it's the same. All right, let's move to the next question. Now, for the next question, they said if he travels 7 kilometers 40 degrees west and not 10 kilo. Okay, right, I'm coming. I think after this we need to check we need to look at what resolution is. So he said if he travels 7 kilometers for, okay, remember I told you always make sure to draw your vertical and horizontal axis, and always remember that this side is your first quadrant, second quadrant, third, fourth. Here is north, which we call y. Here is east, which we call x. Here is west, which we call negative x. Here is south, which we call negative y. So if we know this, let's look at the question now. If you don't draw this and you start trying to interpret this angle, you will make mistake. So if he travels north of west, from the north, he's traveling 40 degrees towards the west. It's very important. From here, you get the angle. So I get this angle. And then 10 kilometers to the east. See the question. If you travel 7 kilometers, and this is 7 kilometers, 40 degrees, and then 10 kilometers to the east. Find the resultant displacement. So notice that what we do here is to say angles. What we've created here is like from here to this way. Then we ask ourselves, angles from this point to this point is 90 degrees. 90 plus 40, everything here gives you 130 degrees. 130 degrees. So if I'm going to use this 130 degrees, I'll simply go to my quadrant. If I'm using resolution, I'll go there and do x, y. I'll come and say in the second quadrant, x is negative, y is positive. I just go and put minus and plus for anything I'm solving using this angle. But I told you I don't like using this angle. I like to do total angle there. From here to this place that this thing enter the second quadrant, total angle in the second quadrant is 180. So I'll do 180 minus 130. I have this remaining, and that is 50 degrees. It's this angle I'm going to work with, because there's a rule that says that once I'm starting from the zero, the origin, and going around, I don't need to be putting minus or plus. That is why you have 180, you don't have any negative to it. 270, you don't have any negative to it. 360, going around. But once you are not obeying this, you must go and obey that part of putting signs on this. And I know we've done it in class. If you put sign here, put sign here, then use this 130. Then I'm obeying all those rules. Then you now come and see that if I'm pulling this 130 now towards y, to y, is now closing the angle. What I will now use is going to be towards the angle cos. It will still give you an answer. Then you now do pulling this 130 now away from the angle is going towards x now. You will now use sine. Then notice whatever you get, you still go back and put all these signs. You will be correct. It will be the same answer with when you do what we are going to do. So me, I'm going to use 50 degrees by doing, I've done 180 minus 130. So if I do now, trying to close this angle towards x, and this is 7 towards x now is towards the angle. That is carrying this to x is towards the angle. So it will simply be, let me draw another one, x, y. Okay, let me use this one. Okay, let's do this, x, y. So I will have 7 cos 50 degrees. Then carrying this now to y is this, it will be going away from this angle. So it will be 7 sine 50 degrees. Then let's move to the next one. There is another angle given to us here, which is 10. Notice that this 10 is only on the east, on the x-axis. I come and put it 10. I don't have that 10 on y. Because anything here, and if it's only for y, anything here is only for x. So I just come and put 0 here. So do it. Let's get 50 cos, let's get 7 cos 50. 7 cos 50. I get 4.5. Then let's do 7 sine 50. I get 5.36. So by the time you add it up, you get 14.5 here. Then here you get 5.36. So if you do this, now I remember I told you once you're able to get x and y, use Pythagoras, because what you've gotten here is now y 5.36, x 14.5. So use Pythagoras to do r square equals to 14.5 square plus 5.36 square. So r square is going to be equals to 14.5 square. So 210.25 plus 5.36. The solution of vector will always be right, so it's better you always do that one first. 5.36 raised to power 2 is going to give you 28.73. Add it together. So I'll have 238.98. Now take the square root of both sides. This will cancel this. So r will be equals to square root of 238.98. 238.98. R will be equals to 15.46. And remember the unit is in kilometer. That's my resultant. They're telling me to find resultant. And whenever you get to resultant, if they ask you to find the angle or the direction, you use tan. And when I'm using tan, notice that what I have here is positive. That means my direction will be in the positive axis. That is in the first quadrant. Assuming what I have here is minus and what I have here is plus. When I finish solving my angle, I'll go back and check which quadrant is y negative and x positive. Then whatever quadrant it is, I subtract the value I've gotten from that quadrant. So, but since everything is this way, it's going to be in the first quadrant. So I've gotten my resultant. Now that I've gotten my resultant, I can use cosine rule to check if I'll get the same answer. So I can say I have this and I have this. And the angle I have here, 40 and 90, is 130 degrees. So by the time you do this, that is projecting this one up. So you should have this angle. This is your R. So this is 7 kilometer and this is 10 kilometer. So the angle you're using is 130 degrees. So if I do R square, once you always use this angle facing us, R square equals to A square plus B square minus 2AB cos 130 degrees. The angle facing resultant is what you must use. If you fail to use this angle facing resultant, you will fail it. So even if it's not given, you check the one given. Whatever angle you're given, by the time you subtract it from 180 angles on a straight line, you get this. Angles in a triangle is equals to 180. So you now have R square is equals to 7 square is 49 plus Shebi. That's what they give us. 10 square is 100 minus 2AB. 2 times 7 times 10 is 140. Then cos 130. So let's do it. Let's first of all, I know cos 130 should be on the negative. So cos 130. So let's do 140 cos 130. So we get negative, and notice that this is 140. So we get negative, we get minus, which is plus 89.99. Then 100 plus 49 r square is equals to, so let's do this. We now have 49 plus 100 plus 89 point 99. So we get r square is equals to 238.99. So r is equals to square root of 238.99. r is equals to 15.46 kilometer. So this is the final answer. So where is that problem is that day in class is this. It must be angle opposite the resultant. So alright, they said define resolution of vectors. Describe resultant vectors. So resolution of vector, let's define it. We define resolution of vectors. That's right. We define resolution of vectors. We define it as the process of, or you say whereby a single vector, process of taking a single vector into x and y components. So resolution of vector is the process of taking a single vector into x and y components. Or you say it is the process where a single vector is broken down into two components. Consider it is also a process whereby two or more single vectors are broken down into two components, and these two components is what we call the x and y components. So that is for resolution of vectors. Now they ask again, describe resultant vectors. So resultant vectors, so we define resultant vectors as the sum of two resultant vector. We define it as the sum of two or more single vectors. So we define it as the sum of two or more single vectors. Resultant vector defined as the sum of two or more single vectors. Even we can define it as the sum of vectors on x and y axis. The sum of vectors on x and y axis. We can also define it as that single vector whose effect is equal to the effect of vectors on the x and y axis. So whichever way you want to take it down. So in our next class, we'll continue from how do you resolve more than two vectors. Then we'll move into multiplication of vectors, dot product and cross products. Thank you for staying with us. Subscribe, share, like.